Now the Newton's second law for the vertical motion, let's explain that through an example. There is a person sitting on an elevator and the combined mass of 600 kilograms, as you can see here, up is positive, down is negative. Elevator cable exerts a force of 6,500 newtons up on the elevator. Find the acceleration of the person. Don't be confused by these descriptions. It's basically telling you 6 by 100 in this case, that would be 600. 6.5 by 1000, that would be 6,500 newtons. Just the author is trying just to confuse you here. There's no need for that as long as the number can be simplified without allocating a lot of space. What's given? We have the total mass. It's given to us 600 kilograms. The total force exerted by the cable. You know that elevator have a cable that's pulling it upward and downward. That's how it works. And it's kind of a force pulling upwards in this case. That would be 6,500 newtons up, and the gravity or gravitational acceleration would be 9.81 meters per second squared downward. Free body diagram, you have F tension, the tension of the cable pulling upward, and you have the gravitational force pulling downward on the elevator and the person system. In this case, the elevator and the person are one system. The system is not accelerating left and right, it's just going up and down, so the F net on the horizontal axis would equal to 0. But for the vertical direction, we write the equation to find the net force. We have F tension up, F gravitation down, the F net would be going upwards. F net would equal the F tension plus the F gravitation, and we know the F net would equal m, or the mass, by the acceleration. Just compensate that and keep everything the same on the right hand side. It equals Ft plus Fg, and we have here A as a simplified form would equal F tension over m plus g. What he did, he just basically reduced Fg to be mass by gravitational acceleration, mg. We know that. We can eliminate now m and rearrange the equation and simplify it, then compensate the numbers, or you can just compensate the numbers right away based on what you're given, and your final acceleration answer would be 1.02 meters per second square going up. Let's take another example. We have a skydiver jumping out of an airplane. During the first few seconds, the parachute is unopened. The magnitude of air resistance acting on the skydiver was 250 newtons. Acceleration of skydiver during this time was 5.96 meters per second squared down. Find the mass of the skydiver. We have F friction by air pulling him upwards, and we have the gravitational force pulling him downwards in this case, and the F net would look like this. So F friction 250 newtons, acceleration 5.96, and the G is 9.81 downward. You can set your convention, down is positive, up is negative, or vice versa, whatever works for you. What is the mass of the skydiver? Now we draw a free body diagram. That's what we did. Then we know that skydiver not going right or left. We are just assuming here in this example. In reality, he could have. So the F net horizontal is 0. And we know that the F net vertical equals the Fg plus the F friction. Now, if you apply the Newton's second law, F net equals Fg plus F friction. F net can be represented as mass by acceleration. That's what it is. Then we have Fg as mass by gravitational acceleration, and we have F friction as minus 250 newtons because it's upward, and your convention is set to have plus to be downwards. Replace everything as it should be. M would equal 250 over G minus A. We know G and we know A. Replace those values. 250 over 9.81 minus 5.96. Keep attention to the signs here. Then your final mass for the skydiver would be 64.9 kilograms. As simple as that. It could get long, it could get short, but you just do free body diagram for the object. Ignore the horizontal forces since it's a vertical problem. Apply the Newton's second law. Replace F net with mass by acceleration. Replace F gravitation with mass by the G, which is mass by acceleration, but it's the gravitational acceleration. And replace all the values. Do the simplification needed. You get the final answer. There's no complication at all.